Expectation is a concept associated with probability. It's a question that often gets asked in part B of a probability question. And the form of the question is always, what would you expect? So there's two types. So I toss a coin 50 times. How many heads do you expect? Okay, well, only one answer makes sense if you really do think that the probability of a coin landing heads is half, and that's 25. Because expecting 26 heads makes it funny that you think the probability is half, because if you're expecting 26 heads, why wouldn't you say the probability was not half, but 26 out of 50, which is a little bit more than half? So type 1 questions are really very straightforward. If you want a fast way of doing them, it's very simple. It's number of repetitions times the probability of what you're interested in occurring. So that's how I got the 25. It's 50 times half equals 25. Okay. Now type 2 is about money, when you've got investment options. So if I say that there's some investment and it's got 50% chance of giving, well, let's say 40% chance of giving £100 and 60% chance of yielding 100 and let's say £200, then what will we expect on average? Okay, now the words on average are important here. What we're doing is imagining that we do this investment every year until we die. In some years it'll give us £100, in other years it'll give us £200. If we took all those years and added up all the yields that we got and divide by how many years there were, what would that be on average? Well, the way you work out what we'd expect on average is to do the probability times the amount and just keep doing that and add them up until you've covered all the possibilities, and that's your expected value. So for me it's 40% of 100 plus 60% of 200, which is £40 plus 60% of 200 is £120. So the expected value of this investment is £160. Now, at first blush that seems a bit ridiculous. How can we be expecting £160 if the investment could only give us £100 or £200? It certainly can't give us £160. That's not one of the two things that it can do. Again, that's why I use the expression, what do we expect on average? So the average figure, if we did this for 100 years or 1,000 years, would be that there'd be a whole bunch of 200s, a whole bunch of 100s. If you add them up and divide by how many there are, your average will be 160. Like I set up with the coin example, nothing else other than 160 makes sense if you really do think the probability of getting 100 is 40% and the probability of getting 200 is 60%. It's the same way as nothing else makes sense other than 25 if you really do think the probability of getting ahead is a half.